All right, so now for part two, we're going to talk about the midpoint formula. And so the midpoint formula, how we get there is the coordinates of the midpoint of a segment are the averages of the x coordinates and of the y coordinates of the endpoints. So how do we do average? So average, we're just going to add up the two we have, divide it by 2. So here we just got x1 plus x2 over 2. And to find our y coordinate of the midpoint, we're going to do y1 plus y2 over 2. That's going to give us the coordinate of the midpoint. So something like this. Here's our handy dandy point A and B. And A has an x and a y, and B has an x and a y that's different than A's x and y, which is all the x1, y1, x2, y2 means. And then right in the middle, we're going to have the midpoint, and its x and its y is going to be at a different number, and it's going to be the x of the midpoint and the y of the midpoint. So this is what we're trying to find, and we do that by finding the averages of our endpoints. So let's look at a couple examples and see how this will work in practice. So as a reminder, let's write down our midpoint formula so we don't have to scroll back. Okay, so the endpoints of RS are R, 1 minus 3. So we go over 1, down 3. So here's our R, 1 minus 3. And our S coordinate is 4 and up 2. There's our S. And somewhere on this segment is going to be the midpoint. Remember, lines do not have midpoints because they don't have middles. They stretch forever. Half of infinity is still infinity. So let's find our midpoint. So x equals x1 plus x2 over 2, y equals x1 plus, or y1 plus y2 over 2. So 1 plus 4 is 5 halves. Minus 3 plus 2 is negative 1 half. So our midpoint is at 5 halves, negative 1 half. So let's go ahead and plot it and see. So we go 5 halves, which is reduces to 2 1/2. So we go 1, 2 1/2. And we come down a half, and there's our midpoint. On our segment, right exactly between the two, which creates a circumstance where RM and MS are congruent. Let's do another example, but let's throw a little curveball. So our midpoint formula is the x of the midpoint is the average of the x's of the endpoints and the y of the endpoints. Well, here they give us the midpoint and one endpoint. So we go endpoint 1, endpoint 2, midpoint. Well, in this case, we know endpoint 1 and the midpoint, so this is what we're going to substitute for. So M is at 2, 1, that's our midpoint. Our one endpoint that we know is at 1, 4. We got to find the other one. So let's substitute for what we know into the same formula. So the x of our midpoint is 2. The x of the endpoint we know is 1. The x of the other endpoint is, I don't know, so we're going to leave it x. The y of the midpoint is 1. And the y of the endpoint I know is 4. Endpoint 2 is I don't know, we'll leave it a y. So here we're dividing by 2. Well, we don't want to deal with this fraction, so let's multiply both sides by the numerator, by the denominator. And here we get 2 times 2 is 4. Here we get 2 times and divided by 2, so they cancel. And 2 times 1 for our y is 2. These two cancel. Clean, little, very happy formula. So let's get the x by itself, subtract 1 on both sides. So 3 equals x. Solve for y. So our missing endpoint k is 3, negative 2. So let's plot it on there and see if they connect. So we go 1, 2, 3. Down 2 is our k. 3, negative 2. Let's connect these. Oh, look at that. Straight line connects all the dots. Success. So now that we know how to find the midpoint and find an endpoint, if we know one endpoint and a midpoint, let's do a couple more examples. So let's do this example. Write my formula down so we don't forget. Okay, so here we have 2 endpoints. X equals 1 plus 7 over 2, and y equals 2 plus 8 over 2. So x equals 8 over 2, or 4, and y equals 10 over 2, or 5. So the midpoint is 4, 5. Pause the video, do the next one, then start it up and see how you did. All right, let's find the midpoint of AB using our same midpoint formula. So we have x equals negative 4 plus a negative 6 over 2, and y equals 3 plus 5, also over 2. So negative 4 minus 6 is negative 10 over 2, so x is going to equal negative 5. Y equals 8 over 2. Y equals 4. So our m equals negative 5 and 4. A couple more examples before we move on to the next thing. All right, so here we have the midpoint and one endpoint. And just for the sake of keeping it simple, I'm going to rewrite my formula, except I keep writing x's when I mean y's. So we know a midpoint and an endpoint. So this is what we're going to substitute for. Let's get the same color. These are what we're going to substitute for. So the x of the midpoint is 2. The endpoint I know is 1 plus x over 2. The y of the midpoint is 4. The y of the endpoint I know is 1. So once again, we are going to get rid of this fraction. And then we're going to get rid of the fraction on the y side. Those cancel. That's 8. Those cancel. So x equals 3 and y equals 7. So the coordinates of u are 3, 7. Pause the video, try the next problem, and see how you do. All right, let's find our t. So here we got minus 1, 4 plus x over 2, and negative 2 equals 4 plus y over 2. Multiply both sides by 2. Cancel. 4 plus x. So we get negative 2 equals 4 plus y. So you get the x by itself, so we get negative 6 equals x. And see here, I didn't multiply that through by 2. That should be negative 4. Because 2 times negative 2 is negative 4. Negative 4 minus negative 4 is negative 8 equals y. So our t is negative 6, negative 8. And you can plug it into the regular formula and see if you get the midpoint, which you will, because algebra works both ways. That is our midpoint formula. The last thing we have to talk about is our distance formula. So with the distance formula, if A is x1, y1, so that's down here, and B is x2, y2 up here, if we have the x's where the y doesn't change, so it's on a horizontal plane, we could do this. If the x's don't change and it's a straight line up or down, then we could do the absolute value of the differences. But that's not real life. Things go sideways. So we got to be able to handle it when it goes sideways. And we do that via the distance formula, which is the square root of x squared minus x1 squared, x2 minus x1, property squared, plus y2 minus y1, quantity squared. And what that's going to do is that's going to square it, and we take the square root, so we'll get an absolute value, and we can find the difference between them both having moved on us at the same time. So let's do an example. Make this a little clearer. So our school, your school, is 4 miles east and 1 mile south of your home. The recycling center, where your class is going on a field trip, is 2 miles east and 3 miles north of your home. So since both are in relation to our home, we're going to make our home the origin, 0, 0, because that's what makes our life the easiest. And we're going to lay a compass down on our coordinate plane. So school is 4 east, 1, 2, 3, 4, and 1 south. So school is positive 4, negative 1. The recycling center is 2 and then 3 north, 1, 2, 3. So it is a positive 2, positive 3. And we want to know what is the distance between the recycling center and school. How far are we going to have to walk up? And we're going to estimate. So let's find RS. So using our distance formula, we got 4 minus 2 squared plus negative 1 minus 3 squared. Then we just go ahead and solve. So 4 minus 2 is 2 squared. Negative 1 minus 3 is a negative 4 squared. Haven't done anything with the squares or the absolute value, so we got to keep carrying them down. The square root, I should say, not the absolute value. So 2 squared is 4. Negative 4 squared is negative 4 times negative 4, or 16. 4 plus 16 is 20. Now, this said that we get to estimate. So we can take the square root using our calculator and round it off. So if we put it in our calculator and take the square root, we're going to get 4.4721. Well, that rounds off to about 4.5. So if we were to leave it radical 20, we would have an exact number. But since we put in our calculator rounded, we have an estimate. And using a little squiggly equal sign, that means approximately equal to. It means we rounded it. That's important information for us in math to know. So let's do a couple examples and finish this up. So once again, we are going to estimate. All right, so school is 4 miles east and 1 mile south. 1, 2, 3. So school's in the same 4 minus 1 as it was previously. But now we're going to go to our friend's house, which is 5 miles east and 2 miles north. So it's going to be Here's our friend's house at 5, positive 2. And the distance we're going to have to walk from school to our friend's house is our distance formula. Nope. So 5 minus 4 is 1 squared plus 2 plus 1, because I have 2 minus signs. Got to keep my square root symbol since I haven't used it yet. 1 squared is 1. 3 squared is 9. Right, so this is exact. But we get to estimate, so we're going to put in our calculator, and our calculator is going to tell us to round it off to 3.2 miles. All right, pause the video, do this last example, and then we'll work together and see how you did. All right, a park is 3 miles east and 4 miles south. So we're going three east, 4 south. Here's our park. Positive 3, negative 4. And this school is in the same place it has been. Positive 4, negative 1. And we need to find the distance from the park to the school so we can play at the park, and then we can go play at the playground at the school. So our distance formula, as we recall, is x2 minus x1 squared plus y2 minus y1 squared, all under the square root symbol. So let's plug in our values. So we get 4 minus 3 squared plus negative 1 minus a negative 4 squared. So we get 1 squared plus a positive 3 squared. So 1 times 1 is 1, plus 3 times 3 is 9, equals radical 10. Once again, we get to estimate, and our estimate is 3.2 miles, and we are done.